We're going on a trip in our favorite rocket ship, zooming through the sky. Little Einstein, climb aboard, get ready to explore. There's no need to hide. Little Einstein.
Okay, so here's what we're gonna do.
Uh-oh, I gotta get in front of everyone.
So
Excuse me, I got camera.
we'll take yonder ping pong ball,
Oh.
and it's kind of cool when it makes a sound. So it's a pretty tight fit down this pipe. Okay?
Dink.
Okay. So roll it down, and then we're going to take a piece of Mylar. Okay, this is like an emergency safety blanket. We'll put this over this end, and then I'm going to put this coupler over the end of it like this. Okay? So I've got, oh, hold on, hold on. Make sure, Jason, make sure the end doesn't roll off. Right?
You already felt it.
Hold on.
Jason should be very unsure about it. Yeah, very unsure.
Don't roll off.
He's never been given a task in his life.
I don't usually have responsibility.
Instruction requires that.
You have one job, make sure it doesn't roll off.
Don't give him too much pressure.
All right.
Never done anything like this before.
Actually, watch out.
What do you want me to do? It's like,
Okay?
and it's like,
Now, the same thing down here. So, now, make sure that end doesn't roll off. So, here.
I wanna go ho, ho.
it's very content ID. No, it's right.
I can't hold a camera to save my life. There we go, I got it.
Okay, good.
We're good?
Yeah.
Yep.
Yeah.
Wait, what am I doing?
No.
Okay, now what I'm gonna do is that, now, you all move.
Me?
You're right at the right level.
I'd rather solve that out.
Okay, so what I'm gonna do is.
Wait, is this staying here?
Yeah, that's hanging. Okay, actually, center the can like on the end of it. There you go. Okay.
And then,
So, what I'm gonna do is I'm gonna draw a vacuum and I'll remove all of the air molecules.
Air molecules.
So, nature abhors a vacuum. So, basically, in round numbers, this end has a square area of about 1 inch. So that means that there's 14.7 pounds of pressure pushing on this end. So when I draw out that vacuum, nature's going to try and equalize this pressure. So I'm going to have pressure on the inside that's basically going to go to 0. And then what I'm going to do is once I draw that vacuum, I'm going to puncture this end with a screwdriver, and then I'm going to see what happens. So, now, if you're sensitive to loud noises,
Yeah.
you might want to cover up your ears. So, I'll tell you when.
You gotta have to cup your ears.
Not do the elephant ears. Like
I got a little
shirt says.
I got a little.
Elephant ears.
Yeah, do your
I got a little distracted by the fact that I was like trying to see, and he kept on moving, and I was just like,
Not that way,
wait,
Jason.
anything, you got glasses? Huh? You got glasses?
anyway, let's go.
Yeah.
Let's go.
Smile for the camera. Bye.
Okay. 3, 2,
Oh, shoot.
1.
The can went bye-bye.
That went off.
I told you it was
Wait.
gonna
What would happen if one of us stood in front of it?
You get, I've done it. You get a huge red welt that lasts for about 3 weeks.
Oh,
Been
no.
there, done it.
I kinda want to
No.
How many tickets?
So,
It flew all the way over there.
there you go. Okay. So,
One more time. Into the ceiling.
So wait,
Into my head. So I die.
hit you with like 14.
Let's go outside, put it at an angle.
Horse?
well, no, because it's a function of how fast this is going.
Okay.
No, that's
Okay.
really loud.
Oh, okay.
Now, so here's the deal. Was work being done on the ping pong ball?
Yes.
Yes.
Yes. There's a force over distance, right? Is the ping pong ball accelerated?
Oh yeah.
Yes.
Yeah.
Big
Yes,
time.
Okay?
Big
Big
boy
time,
accelerated.
right? So this shows you, the reason I do this is because it shows you the strength of the atmosphere that we have. So you had 14.7 pounds pushing on this end. It's the equivalent of Hank bowling ball. So as soon as I puncture that, and if you think about it, oh, well, it's nitrogen and oxygen and all that good stuff. So in that small area, that was a tremendous rush of these nitrogen and oxygen molecules into there that accelerated that because it was trying to equalize that pressure. So as soon as I punctured it, whoom, okay, you had these billions upon billions of oxygen and nitrogen molecules rushing in to equalize this pressure, carrying this ping pong ball with it, blows out the end, takes out the can.
Monster.
One more time?
Bye-bye, monster. Yeah.
Into bread. Shoot it into bread.
Let's get this bread, boys.
A whole loaf of bread. See how far into it?
How far can we shoot a ping pong ball over
in slices of bread.
Bread unit.
It got three
Bread units.
3.5
Let's get this bread, boys.
We're getting
slices in. There we go.
Let's get this bread, boys.
Let's get this bread.
Don't even put the monster
Wait,
there.
you know the Valper thing,
What?
the Captain Gown orders? Is that
I don't
just
know.
today?
I don't know. Like, I literally have
forgot
no
to
idea
turn
what I'm
my-
ever doing
I
anyway.
forgot to turn my order in.
I mean, I'm probably just gonna.
Break the line, no.
I'm just gonna be screwed come graduation because I'm not gonna have anything.
Yeah, I'm just gonna walk in like this.
I have my brother's old gown.
Was it just today or is it tomorrow too?
No, I'm pretty sure it's due today.
No, it's due on Friday. You can turn it in on Friday as well.
Stand there, Lenny.
Make sure that
Say, it's kind of a bad idea.
Make sure what? It doesn't fall off.
You just.
We're good. Don't worry.
Dude.
Get to get the other side too.
Okay. Oh, a balloon full of paint.
all right.
Okay, Jake.
Now, the other thing that you'll notice is that, and don't look at that end, but if you look at this end, it forms almost like it forms basically a mirror because it's a reflective surface. And we'll get into this in the spring. But it forms a concave surface because if concave, you think of it like it being a cave where you can walk into it. So it forms a concave surface, so it actually acts as like a mirror. So both of those are going to be concaves because you're drawing the pressure from the outside. You're removing those molecules on the inside, and the outside is trying to equalize that out, and that's why that pushes that in. Okay, so we'll try it one more time.
It's the buildup. It's the tension.
And it takes a really, really good vacuum to pull this off. Like you can't do it with a shop vac. Okay, 3, 2, 1.
Oh, you missed. You missed.
Why?
And then it goes shoots out like that.
Berg made a boo boo.
Where is it?
It's still in there.
Where is it?
Happened.
Where is it?
Did it make it down here?
Jason!
Way. I was on my way.
Berg made a boo boo.
No. We shoot this off and then they call the cops.
I know I did.
Yes, now there's multiple booms and now the school is gonna go on lockdown.
Yeah, we're gonna go on lockdown because of this.
Uh-huh.
Now, make sure that end doesn't fall.
Yeah, I really like machine.
Only the most quality.
Yeah.
You already know. I stay out here. Making money moves.
Yeah, you do.
To a bag to show how strong they are.
Hey, let's advertise some of these.
Ooh.
Hey, Joel, get up, Joel.
Shoot it.
All right, you can buy 3 of these for $2.
3 of them for 10.
This is a buck right here. This is a buck. Buy this stuff.
They're
Save
pretty
the planet.
good.
Let's go.
Say the merch. Buy the merch. Buy the merch.
Buy the merch.
Buy the merch.
We're advertising merch.
Get some merch. 3 bags, $10. 1 sticker, $1.
Open an online store.
Get a close up of the monster.
You should sell t-shirts. That's the next step in the merch. And hoodies.
Well, aren't hoodies in like the thing?
Oh yeah. We gotta sell them all.
Okay, here we go. 3, 2, 1.
You missed again. You're bad at this game.
It's not blowing out the end.
Like, it's the.
Is it actually?
Yeah, I hit it that time.
Is it actually?
Mylin's too strong.
Or could it be colliding with a coupler? Could it be colliding with like the coupler thing?
Okay, we'll try one more time.
One more time.
Uno más.
Hold that in. Jason.
The ball, go to the other side.
Yeah, no, they live upside down, so they're just used to it.
You're so right.
Buy the merch.
Pangea.
Buy merch.
Buy the merch.
Buy the merch.
Buy the merch.
Show stuff. You can save the planet today. Only $10.
Only 3 easy payments.
Buy the
of
merch.
making that.
Buy the merch.
What are you doing with my...
He has to sell the merch.
You have to sell the merch.
Advertising the merch.
Trying to get people to buy the merch.
Then I'd be like my brother.
Right there.
Then I'd be like my brother.
Okay, I'm gonna get my debit card out, show it in front of the camera.
And the 3 of you left.
Last time. Can you guess what the
One more time. One more time. One more time. One more time. One more time.
needs your help?
All he needs.
Hard at work? Or hardly working?
Numbers on the back.
Needs your help.
Oh shit.
What?
I almost dropped it.
I don't know, there isn't a hole somewhere because I'm not wrong.
There's no hole on this side.
Does that look like it's drawing at least?
I mean, it draws, but it's got like.
Oh, whoa, it is a mirror. That's sick. I'm upside down. I'm standing on the ceiling. And that one.
Okay,
Look, that's us right there.
3, 2, 1.
Take that, can.
Take that.
Boo.
The ping pong ball did not go out, but it broke it.
It was just the air that came out of it.
I can't actually do it.
Hold this thing.
Okay.
It's just the design of it.
There's a video of me.
Okay, back here.
We're going on a trip in our favorite rocket ship, zooming through the skies. Little Einsteins, climb aboard, get ready to explore. There's no need to hide. Little Einsteins.
Oh, did you like
Subscribe to Burkamp.
Buy the merch.
Burkamp BT series.
Yeah, how Burkamp BT series.
Okay. All right, so here's what we've got. So,
She wants to know who's your best friend. I said it was her.
okay. So, one of the equations that we're spending a lot of time on is this. Q equals M, and if you've been in chemistry, you've seen
MC Delta T.
What about MCAT?
Yeah.
No, it's an aptitude.
Okay. Now, physics is a slightly different approach. So if you look on...
I'm still going to use MC Delta T.
Huh?
I'm still going to use MC Delta T.
That's what I have.
I know, but it's just in a different order.
Yeah. It's spelling.
I'm still going to use it in a different order.
How we learn.
What do you want?
Different order.
I want MCAT.
Yes.
Yes, MCAT.
That's the way to do it.
MC Delta T.
That's the format right there.
Oh,
Oh no! Oh no!
I hate
He's gonna take off
do
points
that.
from our assignments.
Guess what? You're still going to get the same answer.
I'm not gonna.
Sure, man.
I don't know.
Are you sure about that? Are you sure about that?
Okay. So here's what I want to look at. So on this situation, which one do you prefer?
MCAT.
MC Delta T.
MC Delta T.
I'm all about trying to accommodate my students.
Yeah.
The board knows your true feelings.
Oh, I know, that's the one that you really want.
Wait,
Why are
wait,
you
it's
so
fun. Slow.
It's like it sucks it in.
It's a black hole.
Sort of a black hole.
It is! It's like an electron black hole. Okay. Alright. It's the event horizon.
Technically,
Black
doesn't
hole.
everything have an
And the accretion disk. Okay. So the M is going to be what? Mass. Now, in chemistry, mass is measured in?
Kilogram.
No, not in chemistry.
Grams.
Oh, chemistry.
No.
No, mass is definitely not measured in moles.
Grams.
That was in grams, right? Okay. So since we're in
Jason.
physics, it's going to be in
Kilograms.
kilograms. Now,
You're a loser.
what?
I know.
Sorry, but
Hurry, run.
so, the specific heat is the amount of energy that it takes to change the temperature by 1 degree Celsius per kilogram. So if you look on yonder sheet, okay, you've got specific heats of various substances. Now, here's one of the most important ones. Notice that water has a very, very, very high specific heat, 4,186. Notice that that is the biggest of all the substances that are there. So what that means is that it takes a lot of energy to change 1 kilogram of water by 1 degree Celsius. So if you look at water, 4,186 joules per kilogram degrees Celsius. Now here's the odd thing. Sometimes you'll see this as Kelvin, and it doesn't make any difference whether it's Celsius or Kelvin because this is change in temperature. So like if you're at, and this is what we talked about yesterday, if you're at 20 degrees Celsius and you go to 21 degrees Celsius, that's like saying you're at 293 Kelvin and you're going to 294 Kelvin. So it's still 1 degree change. So because this is change in temperature, it doesn't make any difference if your change is in Kelvin or if your change is in Celsius. But here's what's important, just like that thermal expansion stuff that we talked about yesterday. It isn't the temperature itself, it's the change in the temperature that's going to be important. So when you look at this, if there's no change in temperature, guess what? There's no energy that's going to be involved in this. So this equation only works when you have a change in temperature. And clearly, the bigger the temperature change, guess what? The more energy that's going to be involved. So from a unit's perspective, this mass is going to be in kilograms. This is in Celsius or Kelvin. It doesn't make any difference because it's the same thing. So your kilograms cancels out, your degrees Celsius cancels out, you get joules, boom, that's your amount of thermal energy. Now, if you take that thermal energy and divide it by time, then what do you get? Power, otherwise known as watts. So if you look at microwaves, a lot of microwaves are rated in watts. Like a typical microwave is around 1,100 watts. So what that means is that microwave can generate 1,100 joules of energy per second. So the higher the wattage, the faster you can warm stuff up in your microwave. That's the short version. Okay, so this calculation itself is pretty simple. But here's what's going to be important. This is going to be involving a change in temperature. Okay, so if there's no change in temperature, this calculation doesn't mean anything. So, if you look at this in terms of specific heat values, so you notice, let's say for example, copper. Copper has an extremely small specific heat. What that means is that it's really, really easy to heat up copper or let copper cool down. Okay? Boom, here you go. It's because it doesn't take much energy. But if you have a kilogram of water, that's going to take a tremendous amount of energy. So if you look at water being 4,186 joules, so to give you some perspective on how much this is, okay, if you have a kilogram of water, that's about 2.2 pounds, which is about the equivalent to fill up this cup with water. Okay, roughly. So if I take a 1 kilogram mass, okay, let's just say the gravitational acceleration on Earth is 10. Let's say just to make it easy. So,
Wow, it is 10.
My pencil gun like that.
gravity just gets stronger?
It's 10 now.
Okay, it's 10 now. Okay.
Gravity
There's some
storm.
kind of
Oh
gravity
no!
Okay.
I don't know.
What about your pinky?
Feel it.
Okay. All right. So if I take a 1 kilogram mass, and let's say G is 10 meters per second squared, and I lift it up to a height of 1 meter, how much work did I do?
10 newtons.
Actually, not that many.
10
1
joules.
kilogram,
Oh shoot,
G
not
is 10,
newtons.
this weighs
10 newtons.
10 newtons. I lift it up to a height of 1 meter, I do
10 joules.
10 joules of work. So what this means is that this is 4,186. So to do this equivalent amount of work, to get the energy to change it just by 1 degree Celsius, I would have to take this and lift this up about 420 times. Okay? That's the same equivalent to take 1 kilogram of water and change it 1 degree Celsius. So to do this 420 times, okay, if I could harness that energy, I could heat up and change the temperature of a kilogram of water by 1 degree Celsius. Now, copper would be simple, because if you look at the specific heat of copper, the specific heat of copper is 390. So for copper, I'd only have to do it like 39 times, okay, to generate enough thermal energy to change the temperature of copper. So it's both a good and a bad thing in terms of water. So if you have a pool, okay, number one, it's a huge water source, but water has very, very high specific heat. So what that means is that it's very hard to change the temperature of water. So it takes a lot of thermal energy to get it warmed up, okay, in the springtime going into summer, but then as you're going into fall, it'll retain that heat because it has such a high specific heat value. Now, if you look at this in terms of your potential, assuming that you all are homeowners, okay, because water has such a high specific heat, if you have outrageous electrical bills, natural gas, if you use natural gas, quit using hot water or as much hot water because, oh, I want to go take a 30-minute hot shower. Okay.
That is the line.
Bird, you said that last year, and that's literally like the one thing that stuck with me for so long. like, obviously I know chemistry now.
Yes.
But
I hope so. My God. If
Like
you don't,
for
I
my
failed you.
daily life, like every time I take a shower, that goes through my head.
Yeah.
That you said that.
Because,
I'm like,
I mean,
oh God,
if
I
you
gotta
look
get
at
out.
this calculation,
I don't want that knowledge in my head.
it is a tremendous amount of energy to heat up water because it has such a high specific heat value. So if you look at like the energy consumption in the United States, we spend a lot of energy heating up water so that you can take hot showers. So literally, once you become homeowners and not homeless taking showers at the YMCA.
Fun to stay at the
Nothing wrong with that.
YMCA.
I was in grade school when that song came out and I hated it then. We actually
What song did you
that
not
song
hate?
as part of-
What song did you not hate?
Oh, I hated it then. The Village People, oh my God.
No, what song did you not hate is what I'm saying. What's a song? Name one song you didn't hate.
When I was in grade
Name one
school,
TV show.
Yeah, and when did
Beach Boys. Okay.
wait, which one?
Beach Boys. I don't know.
Okay,
What was the second thing you said?
TV show.
Mike Love.
TV show?
What TV show did you not hate?
What age group?
Ooh, what age group?
Pick one.
Finding Nemo.
What TV age group?
Big
Let's
Bang
say-
When I was in
Theory.
high school,
Yeah, let's say high school.
MASH was good.
Okay, alright.
Okay.
All right.
What's your
I just needed to have a
I like Big Bang
don't
Theory.
recall.
like Backstreet Boys?
Okay.
Yeah,
Never saw it.
It's not a movie.
It's not a movie.
That's it's a musical
the
group.
band? No. God, no. Have we met?
There's some Backstreet Boys when I walk in tomorrow.
Bad.
I'm gonna be bumping through Backstreet Boys.
Kenny Chesney.
like Charlie and John?
Huh?
I feel like you'd be like a jazz type of guy.
You like
Sometimes.
jazz?
Jazz.
Is that a B-movie
That's
quote or
probably
something?
wrong.
Yeah, that's what he says to the girl. He's
Yes,
like,
rock it out.
you like
That's
jazz?
the real fan favorite.
I quote that all the
Or
time.
from
Okay.
Star Wars, you like jazz?
Now,
You like jazz?
the other thing that's on here is this part down here where it says temperatures of phase changes and latent heats. So you have two big equations. The other one is Q, here's the first one. How do you guys want it?
In cat.
MC delta. MC delta.
Now, here's the other one. Now, the good news is tonight y'all don't have any homework.
Oh,
Is that a T or an S?
What?
The first
Here?
part. Yeah.
That's an F.
That's
Yeah.
That's an F.
That looks like an
They
F
gotta
to me.
practice.
What does it stand for?
So,
Fake.
That's
Stands
what
for
he's
fake.
doing. He's teaching me.
The LVF level up.
I'm not trying. I'm
Wait.
figuring out.
Well, look.
Latte heat.
Latte heat. Whatever your temperature your coffee is.
Okay, good.
That's
That's what that is. That's what
fusion.
A fusion.
Nuclear
F is equal to V.
Look at that. I don't remember
I
that.
know.
No.
Wait, then what does MLK stand for?
Yeah.
Martin Luther
Martin Luther King?
No, but like, I know that, but like, it would stand for something else in physics.
okay,
No, Martin Luther King still.
so anytime you have a phase change, you're going to talk about either latent heat of fusion or latent heat of vaporization. So, when you talk about latent heat of fusion, do you think that's boiling water or making ice?
Fusion is probably.
Fusion.
Making
That's
ice.
the
Making
thing,
ice, yeah.
because you're going to take water molecules and slow them down enough where you can form hydrogen bonds that lock them together. Latent heat of fusion, or latent heat of vaporization, is boiling water. Now, there's a couple of things that I want to point out. Notice that your MCAT up here, this is dependent upon a temperature change. So it's mass, change in temperature, specific heat. Notice that there's no change in temperature here. So this is only dependent upon mass and latent heat of fusion and latent heat of vaporization. So in terms of us and our existence on Earth, notice that water, you have an LF. This is involving melting, boiling, or melting and freezing. That's 3.33 times 10 to the fifth. Notice that the boiling point, your latent heat of vaporization, is 22.6 times 10 to the fifth. So what that means is that it takes a tremendous amount of energy to boil water. It still takes a lot of water to like melt ice, but it doesn't take near as much energy to melt ice as it does to boil water. So notice that, and the units are a little bit jacked up, because if you notice the units, it's joules per kilogram. Specific heat are joules per kilogram degrees Celsius. So the reason that is joules per kilogram, number one, is that the units work out. So this is just going to be in kilograms. This is joules per kilogram, so when you multiply them together, you're just left with joules. So when you see LF, this is going to be a phase change involving either melting ice or either melting it or forming ice. This is either going to be boiling water or having water condense from a vapor into a liquid. This latent heat of fusion is like an order of magnitude bigger than the latent heat of fusion is. Okay? So this is takes a lot more energy. So tomorrow, what you'll see is, and we'll go through this in examples, is that when you have this latent heat of fusion or latent heat of vaporization, you're dumping energy into a system, but if you're talking about like ice, that latent heat of fusion is going to break the bonds. You're not changing the temperature. With this one, with latent heat of fusion, you're dumping energy into a system, but it's going to boil water, and you're breaking the bonds that hold the water molecules together. So you dump energy into this equation, and you change the temperature. You dump the energy into this system, you're breaking bonds. So both of these involve either adding energy and breaking bonds, or removing energy so that bonds can form. Energy here goes into changing kinetic energy. From an energy perspective, you dump energy into here, it involves changing the amount of kinetic energy because it's going to warm up. Here, this is actually a function of potential energy. So if you're like boiling water, you're taking those molecules and you're dumping energy into them and you're storing potential energy, and then when it breaks those bonds, that potential energy changes into kinetic energy, and then you have vapor. So, we will finish this discussion on the morrow. You have no homework tonight.
You say on tomorrow?
On the
Tomorrow.
On the morrow.
We're being fancy boys. What's yours? I got this laminate copy for there.
Why is it? What is it? Why?
For what?
The same mechanics and why?
Well, your temperature change in Hawaii can be a lot less than Kansas. Kansas goes wild, Hawaii doesn't. Yeah, that's what I put too. Kansas has greater period.
What?
I go down the hall, tell my sister to ride the bus.
Yeah.
I didn't do that.
So bigger locks, bigger expansion joints when you need it.
Yeah, I said more or stronger expansion joints. I don't know if that's the right word for that.
My brother is too going to get freshman.
So you really can't escape.
Oh, I can escape.
Andrew said I can and I will.
I
put I put my name on it. Yeah.
I remember because. So do I need to target 19 with this assignment?
Yeah, I did.
Why should my Friday tomorrow?
Yeah, on the front of this it has Wednesday and Friday because they have representatives from there taking it.
Okay.
So they can be yeah. Fine. Oh Jesus! That actually kind of
What is that? Was it brand of something?
Yeah.
Gas?
that scared me. That scared me more than a yeah.
The thing doing it.
It's because his dad did. Like,
Better with my eraser.
Yeah, it's cool. I think his dad found his dad.
Show me those.
What is your
My
dad?
sister told my sister.
no, what happened was
It's a B?
the guy that. So Sullivan is Brandon's dad was adopted. I'm bringing water bottle. He lives with his stepdad in his house. And his real dad is a piece of shit. So he took his stepdad's name because he didn't like his dad. In my defense, and then it just trickled down. If that makes sense.
My brother, his dad did like the back together.
It was like,
I want the rest together. They changed it back to him. Because like, why are they changing it?
So it's your brother. My brother. What do you mean?
So many. Why did they change it?
No, because his real dad just like wasn't there at all.
Oh, so
We have so many
real name.
Yeah.
In our house, they changed it to
Yeah.
step uncle or step grandpa.
The guy that raised him. The guy that raised because he's too lazy to coach stuff.
So they didn't like find me, like they already knew they were.
Yeah.